Cyber resilience, building defenses against next-gen cyber threats in an era where digital transformation accelerates at an unprecedented pace. The landscape of cyber threats evolves with equal velocity. Organizations face a critical challenge, not just protecting against current threats, but building systems resilient enough to withstand and adapt to the sophisticated cyber attacks of tomorrow. This shift from traditional cybersecurity to cyber resilience represents a fundamental change in how we approach digital defense in the modern age. The evolution of cyber threats. Today's cyber threats bear little resemblance to the simple viruses and malware of the past. We now face advanced persistent threats, APTs, quantum computing challenges, AI-powered attacks, and increasingly sophisticated social engineering techniques. State-sponsored actors, organized crime groups, and individual threat actors leverage cutting-edge technologies to breach even the most fortified systems. The traditional perimeter-based security model has become obsolete in a world where network boundaries are increasingly fluid and remote work has become the norm. Understanding cyber resilience requires acknowledging that perfect security is an impossible goal. Instead, organizations must build systems that can continue operating during an attack, rapidly recover from breaches, and adapt to new threats as they emerge. This approach combines traditional security measures with business continuity, disaster recovery, and organizational adaptability. Zero Trust Architecture. The foundation of resilience. At the heart of modern cyber resilience lies the Zero Trust Architecture principle. This approach abandons the traditional trust but verify model in favor of never trust, always verify. Every user, device, and application must continuously prove their legitimacy, regardless of their location or previous authentication status. Implementing Zero Trust begins with micro-segmentation, dividing networks into isolated zones to contain potential breaches. Each zone operates independently, with strict access controls and continuous monitoring. This approach ensures that even if attackers breach one segment, they cannot easily move laterally through the network. Organizations implement this through software-defined perimeters, identity-aware proxies, and sophisticated access management systems. The role of Identity and Access Management (IAM) becomes crucial in a zero-trust framework. Modern IAM systems incorporate multi-factor authentication, biometric verification, and behavioral analysis. They continuously evaluate not just who users claim to be, but whether their actions match expected patterns. Artificial intelligence and machine learning algorithms analyze user behavior in real time, detecting anomalies that might indicate compromised credentials or insider threats. Artificial intelligence and machine learning in defense. Artificial intelligence and machine learning represent both a threat and an opportunity in cybersecurity. While attackers use AI to automate and enhance their attacks, defenders leverage these technologies to build more resilient systems. AI-powered security information and event management (SIEM) systems process vast amounts of data in real time, identifying patterns and anomalies that human analysts might miss. Machine learning algorithms excel at detecting zero-day threats, previously unknown attack vectors that traditional signature-based detection systems might miss. These systems analyze network traffic, system logs, and user behavior to establish baseline patterns and flag deviations that could indicate attacks. As threats evolve, the algorithms adapt, learning from each new attack pattern to strengthen future defenses. Deep learning networks now power advanced threat hunting systems that proactively search for indicators of compromise. These systems can correlate seemingly unrelated events across different parts of the network, identifying sophisticated attack campaigns that might otherwise go unnoticed. The key to their effectiveness lies in their ability to continuously learn and adapt, staying ahead of evolving threat patterns. Cloud-native security and containerization. The shift to cloud computing has fundamentally changed how organizations approach cyber resilience. Cloud-native security architectures leverage the inherent flexibility and scalability of cloud platforms to build more resilient systems. Container orchestration platforms like Kubernetes enable organizations to quickly isolate and replace compromised components without disrupting entire systems. Infrastructure as Code (IAC) practices allow organizations to maintain consistent security configurations across their entire infrastructure. When security vulnerabilities are discovered, automated systems can quickly deploy patches across thousands of servers and applications. This automation reduces the window of vulnerability and ensures consistent security practices across the organization. Cloud Security Posture Management (CSPM) tools continuously monitor cloud environments for misconfigurations and compliance violations. They can automatically remediate common issues and alert security teams to more complex problems. This proactive approach helps organizations maintain a strong security posture even as their cloud infrastructure evolves and grows. Quantum-ready encryption and post-quantum cryptography. The looming threat of quantum computing poses a unique challenge to cyber resilience. Quantum computers could potentially break many current encryption algorithms, exposing sensitive data and communications. Forward-thinking organizations are already preparing for this threat by implementing quantum-ready encryption and post-quantum cryptography. Post-quantum cryptographic algorithms resist attacks from both classical and quantum computers. Organizations are beginning to implement hybrid approaches that combine current encryption methods with quantum-resistant algorithms. This ensures continued protection even as quantum computing capabilities advance. Crypto agility becomes crucial in this context, the ability to quickly switch between different cryptographic algorithms as needs change. Organizations build this capability into their systems through modular cryptographic frameworks and well-defined key management practices. Incident response and recovery. Modern cyber resilience strategies acknowledge that breaches are inevitable and focus on rapid detection, response, and recovery. Automated incident response platforms integrate with security tools across the organization, enabling immediate action when threats are detected. These systems can automatically isolate affected systems, revoke compromised credentials, and initiate recovery procedures. The concept of living off the land attacks, where adversaries use legitimate system tools to conduct their operations, has led to more sophisticated detection and response strategies. Security teams now focus on identifying suspicious patterns of legitimate tool usage, requiring advanced behavioral analysis and context-aware security controls. Organizations increasingly adopt chaos engineering principles, deliberately introducing controlled failures to test and improve their resilience. Regular penetration testing, red team exercises, and disaster recovery drills ensure that response plans remain effective as threats evolve. Human factors and security culture. While technological solutions form the backbone of cyber resilience, the human element remains crucial. Organizations build resilience through comprehensive security awareness training, regular simulated phishing exercises, and clear security policies. The goal is to create a security-conscious culture where every employee understands their role in maintaining organizational resilience. Security champions programs embed security expertise throughout the organization, ensuring that security considerations are built into projects from the beginning rather than added as an afterthought. This shift-left approach to security helps organizations identify and address potential vulnerabilities early in the development cycle. The future of cyber resilience. As we look to the future, several emerging trends will shape the evolution of cyber resilience. Edge computing and 5G networks will require new approaches to securing distributed systems. The Internet of Things, IoT, will continue to expand the attack surface, requiring more sophisticated device authentication and management strategies. Blockchain technology shows promise for building more resilient systems, particularly in supply chain security and identity management. Self-healing systems powered by advanced AI will automatically detect and repair vulnerabilities, reducing the need for human intervention in routine security tasks. The integration of security orchestration, automation, and response (SOAR) platforms with advanced AI capabilities will enable organizations to respond to threats at machine speed. These systems will coordinate across different security tools and platforms, providing a unified defense against increasingly sophisticated attacks. Building cyber resilience requires a holistic approach that combines technological solutions with organizational adaptability and human awareness. Organizations must continue to evolve their defenses as new threats emerge, always staying one step ahead of potential attackers. The future of cybersecurity lies not in building impenetrable walls, but in creating systems that can bend without breaking, adapt to new threats, and quickly recover from inevitable attacks.